FAA mechanic, DER, AC-11 test pilot, I guess. Bought my first Commander in 2001. Aerodyme's got 100,000 hours of experience with Commanders, exclusively Commander for 24 years now. Still free fleet technical support, not just for our own products, but whoever calls. And a lot of you owners might not know that your mechanics are calling, but many of them are. So PMA parts, STC mods, DER approved mRNA, major repair and alteration. Lots of service kits. You may have the handout. Standard parts that we know you need, we try to keep on hand for your convenience, and inspections, and then actually doing the mRNAs on the airplanes. So let's go on to the first topic for today. Aileron bell cranks. I spoke about this once several years ago, but this is a continuing problem across the fleet, is that our aileron bell cranks are becoming structurally unsound. And loss of roll control is a test flight none of us ever wants to make. You know, you've got redundancy in your airplanes in many ways, but you really don't have redundancy in roll control. I mean, you could try to level the airplane with the rudder. That might work for a while, but none of us want to make this test flight. So what's going on with these aileron bell cranks? So let's see. I'm going to try to use my mouse here a little bit. Maybe hard for you to see, but this is the wiring diagram, so to speak, the cabling diagram for the aileron control system. And we're going to be talking about area B out here on the end. I don't know if you can see my mouse, but area B. All right, so area B looks like this in a later model airplane. And okay, and then it looks a little different in an earlier model. It looks like that. You may find that more complex looking weldment in some of the earlier airplanes. So why are we worried about this issue? Well, it's safety. Yeah.
Can you go to full screen on your presentation?
Oh, sorry, forgot. There. Okay. Better?
Yes.
Okay. So again, why are we worried about this? Well, it's safety. Primarily, it's safety. We want to make sure that these cranks are all safe, left and right, in all of your wings. But also reduction of trailing edge flutter, aileron trailing edge jitter, flutter, vibration, which is present to lesser or greater extent on all of our Commanders. And the reason we'd like to minimize that is it wears everything out, right? It's not necessarily a large danger of actual full-blown surface flutter, but it's wearing out the systems. It's wearing out your rod ends. It's wearing out your hinges. It's wearing out everything in the airplane. So we'd like to eliminate that and get those. And when we look out the window, we'd like to see that those aileron trailing edges look like they're not moving at all. And then there's a quality of service factor. I think we all like to have our flight controls feel nice. Our Commanders are famous. They're excellent in terms of balance, control, feels, and that's all wonderful. And we'd like them to feel as nice as they can. You know, nobody likes to fly around with yokes that are loose and this sort of thing. So quality of service is, I think, a factor when we're really trying to have our planes be the best they can be. So in terms of safety, bearing wear, there's a bearing in the middle of this crank. And Don, can you show my, oh, sorry, I'm going to show, you're going to lose my face for a minute. I'm going to show you this. This is the aileron bell crank of the later style. And let me see if I can put that down here on the table for you. Maybe turn the phone over that way. Okay.
There you go.
All right. So there we go. So this is the later style bell crank. This bearing sits in the middle of it, right? And it's attached to it with 3 rivets. See the 3 rivets there? Those are actually cherry rivets. So those are pop rivets. They're not quite the ones you buy at ACE. They're a bit better. they lock. But those are in fact an aerospace pop rivet, blind rivet. So there are a couple of things going on here. Primarily what's happening is that these rivets are not adequate to do the job. So Rockwell kind of missed the boat on that. We've analyzed it. We tested it, full-on test setups. We've made these things fail. We've proven by analysis that they aren't quite up to the task. There were some factors that Rockwell kind of missed a little bit. But then also we said, well, let's see if we're really right about that. So we'll build a test set. We built a test set and gave them the loads that they should sustain. And actually they failed. So it's field data correlates with analysis, correlates with test, everything correlates. So some mechanics have noted these failures by looking up inside your wings. And I'll try to get my face back for you here. All right. All right. So some of your mechanics are quite attentive and have noticed this going on. And so they have noted that the bearings may be worn in some cases. The bearing may still be attached, but worn, very loose, causing a lot of trailing edge play and enough to worry them. And so they punch in this number for the bearing. They look it up in the book. They punch this in MS20218-1. They punch it up. And guess what? It comes up on aircraft spruce. That's great, except that it's not the right bearing. I've gotten on aircraft spruce about this, that they've not been willing to do anything about it. They say, hey, we don't sell anything for certified airplanes anyway, so don't bug us about that. But anyway, they've not been willing to make a move on this. But they are selling an aluminum bearing under this MS20218-1 when actually the bearing is supposed to be steel. And I think you all know there's a big difference between steel and aluminum. They each have their role in airplane design, and this bearing is supposed to be steel, which gives it greater capability. So we just have a plane here in the hangar at the moment, which has one of those aircraft spruce bearings in it, and we're taking it out and doing the procedure that I'll describe here in a few minutes, because that we've tested that bearing as well, and it is not even close to the requirements in there. So we have some airplanes that have picked up the wrong bearing. You could take a magnet, you could stick it up inside and maybe determine, because your magnet might be attracted to the rivets. It might be attracted to the underlying arm, but you're trying to tell, is the housing of the bearing aluminum or steel? Also, if it looked pretty new, then it's probably been replaced by a mechanic thinking he was doing the right thing, but being fooled by aircraft spruce. And the cherry rivets are failing. So they're simply not able to handle the tension loads that are going on in there. And so that's the scoop. Now we'll move on. This was the early bell crank assembly. And the early cranks, the bell crank was designed to be attached at 2 points, high and low. And you can sort of see there are 2 tabs here, high tab above the number 11, low tab down below the number 11. And that allowed this to sit in the wing without rocking. Later on, for some reason, I don't know what, Rockwell decided that maybe that was too difficult, too expensive to do that weldment. So they did a flat plate to replace it. Still has a center bearing. And the trouble with this one with just a single bearing is it rocks. So in addition to pivoting, let's see if I can hold that up in front of the camera. It should do this. It should not do this. It should not rock. But with just one bearing, it does rock. So that adds play to the trailing edges. All right. We'll try to play this little movie, see if we can get away with it. I don't think I see the movie playing. Let's see. Doesn't seem to be playing on your end. Okay, I'm sharing the movie, but it is not playing on your end. Well, okay. I guess we'll blow on past it, but this is trying to look up in the wing and look at a bell crank and look at the steel arm that it's attached to and look at this gap. There's a gap right here where I'm moving my mouse along, if you can see that. And that's gapping open and closed as this movie plays. It's gapping. So what I do when I have a plane come in and the rivets look like they might be still hanging on, no real pathology with the rivets yet, but I'm wondering, is there a gapping going on? I take a 5,000 steel feeler gauge. I try to stick the 5,000 feeler gauge up here between the bearing flange and the arm to which the bearing is attached. I see if I can slide that feeler gauge in there. If I can, then it's time to take action. Okay, so here's what we've done, a new design, which guess what? It kind of goes back and builds a little bit on the earlier design I showed you. You see this uses two bearings. So it attaches to the top of the existing steel crank arm and provides a replacement for the bearing that was at that level. But it also goes up to the upstairs part of this, right? And has the second bearing. So this allows us to be much lower in rock. Our rocking attribute is much improved, much reduced. And these bearings are standard aerospace, snap ring in, easy to maintain if they ever had to be replaced. It's simple. This is a pair of them ready to go. So tested and proven results. Structural integrity is restored. We've tested our own design, of course, to see that it exceeds all the requirements with a proper factor of safety, better than 1.5, which is the FAA requirement. Substantial reduction in trailing edge play and improved quality of service. The whole roll control system feels better. So here we go. Here's the word from our sponsor. These hubs are not inexpensive to manufacture. You know, that's what you can do with a 5-axis CNC right there, and they don't sell those machines for nothing. So what I'm trying to do is build a group buy on this. We've already put them in several airplanes. I'd like to build a group buy so that we can keep the price down for people who'd like to kind of look ahead and set their airplanes up for safer and better and hopefully forever service in this regard. So $395 per side times 2 sides would be $790 and $125 paperwork charge. All right, here's a set where the plane was here. We took the arms out, we cleaned them up, we reprimed, we did the rods, which are sometimes in a mess, and these are all ready to go back in the plane. Now, if you combine these new hubs with good U-joints, compliant spacers, I'll talk about for a minute, and proper cable tensions, aileron flutter, jitter, vibration can be reduced to nil. This is where I am on my own 5LP 114. There is no aileron trailing edge play. It is 0. And that came from these hubs attached to, to the bell cranks, but it also came from having a good condition U-joints. These items on the right, the guy with the orange on it, that's the U-joint. That's where your control yoke column meets the chain and actual yoke weldment assembly. And then there's a spacer which adapts that U-joint to go inside that control column. And that spacer doesn't fit very well. Some of you who've gone in and replaced your U-joints have noted that, yeah, the U-joint's taken care of, but it's wiggly in the end of the tube. And so this compliant spacer, which we've designed, takes care of that. It's a pretty exotic little thing. It's a type of design called compliant design, where your part has a certain geometry, certain stiffness, etc. And when it's installed, it adapts to the condition. So this closes those gaps and gives us a nice tight installation of the U-joint into the control column. So again, if you throw all this stuff at your airplane, you really get a very nice result. Okay. So maybe we'll take a few questions on this and then go to the next topic.
Jim, does
Yeah.
that, um, does your design there fit on um, all commanders?
Yeah, this will do all commanders, at least from 126 and up. The first time we do a 125 or a 125 and down, we'll be paying close attention to make sure that there aren't any issues, because I've never seen a commander with that earlier crank design in it. So it may be that the factory actually never put those in any airplanes, although they're depicted in the IPC, or they may have put them in and then taken them out and never told anybody. You know, they did that kind of stuff on occasion. So the first time we actually encounter a 125 and down with a request, then we'll follow along closely. But we think it all should work fine in all models and serials.
How many do you need, Jim, to make it work?
25, I think I could do that pricing with 25 owners. So that would be 50 sets of this stuff.
No, I had to replace my left one a couple of years ago, and I paid $240 for the bearing, just for that bearing, just for reference.
Yeah, that's right. For a while, the steel bearing, the true intended bearing, had gone out of existence. But then Cessna, because it uses that in its probably in its aileron bell crank, or uses it somewhere, actually got with I can't remember who they went with, Heim or somebody, and they had a run done. They ran 2,000 of the steel bearing, the proper MS 20218-1. And so those are out there on the market now. They're guys are usually asking 250, maybe 500 for those steel bearings. So that's an option. If you thought that was the right way to go, is make sure you're getting the steel housing. But you won't get these other improvements in elimination of trailing edge play and all that, and extra safety margins. You won't get all those benefits, but at least you get a bearing.
When I replaced my bearing, I still have play on my left aileron.
Yeah. That's to be expected. Yeah, because it's the design at the assembly level of the one bearing really doesn't do the job out there very well. It still rocks a lot. If you open the access cover and you grasp the trailing edge of the aileron, and you're out of the control lock, no control lock, grasp the trailing edge, look up through the access, you'll see that as you move that aileron trailing edge up and down, you'll see that bell crank rocking. It's leaning over, lean. And that's play, right? That's directly causing play in that trailing edge. It's one of the major contributors to aileron trailing edge play.
Will you take deposits and then update for your hours?
I didn't quite get that question.
Do you take deposits on it and then update for your hours the numbers?
Jim Jurgen is asking if you take deposits. Okay.
Yes. And then if we couldn't go forward at that price, or we couldn't go forward at all, I'd just let you know and we'd just refund those deposits. But the deposit helps us know that you're really in. You're not just inquiring, you're in. And we wouldn't want to hold that deposit for too long, but maybe hold it for 3 months or 6 months and see if we were going to get anywhere near close to 25 for this first go.
Put a number on the deposit.
How large would you like the deposit, Jim?
Oh, $250 or so would be fair enough. Any other questions on this topic? Don?
Yeah, questions coming in. Hold on a second.
He's asking about whether or not there, without modifying the design, whether or not there's a kit or parts available to strengthen the existing pop rivets and bearing flange?
Well, this is the kit.
Something about
So
that.
I think your options are, if you find a bearing whose attachment is loose, you could reattach that differently. I've seen airplanes where that's been noted by inspector, and the bearing has been high locked to the arm. So that's reasonable. Or maybe they've added rivets. So they found all three rivets in trouble, and they've replaced the three and they've added more. So these are strategies to get that bearing reattached. And that is the primary safety hazard. But then if you want to get at the rocking and the edge play and all that stuff, then the kit that I'm showing you here is how to address that.
And weight, those look pretty key.
How do they compare in weight to what you're replacing?
Oh, it's insignificant. Wouldn't even be a weight and balance item. They don't weigh enough. These are aluminum. These hubs are aluminum, and so they don't weigh enough to really show up on weight and balance.
Now, do they come on the bracket, or do you need to attach this to your existing bracket?
Either way. So you could have your mechanic drop your cranks out of the wing, send them to me, and we do the attachment. Or we send you the kit, which has the hubs. So we'll go back to, we send you this setup here, along with some screws and rivets and other stuff. We always do that in our kits. We try to put in there what we know you're going to need that you might not have on hand. And then you would attach them yourselves in accordance with the instructions that I provide. So you could go either way.
Jim, just to confirm, the existing Cherry Max that are in there, those are steel bodied Cherry Max?
That's a steel shank. And sorry, yeah, those should be Monels. They should be Monel cherries. They should have a little M marked on the head, on the factory head. There should be a tiny little M. Now, you don't always find that those are Monel cherries because, again, if somebody's been in there and they might have said, "Oh, those are cherries. They're failing. I'll replace them with new cherries." They might not have noticed they're Monel, because the Monel is a steel combination.
Locking color. The Cherry Max is locking colors that's on there, or are they cherry locked?
He's asking if there are locking collars on the existing Cherry Max.
Yes. These were CR 2249s, we think. We think it's a sort of the older style Cherry Max, sometimes called a bulb lock. But they did have both friction on the stem. When they're in the lock configuration, the locking came from two places. The locking ring drops into place, and then a friction component that also helps to retain the stem remainder. CR 2249s. We think. By the way, cherry rivets, because here these are loaded both in tension and in shear. Cherry rivets are rated by Cherry Aerospace in both tension and shear. The FAA has never been a believer in tension on cherry rivets. And so the FAA gives them exactly 0 tension credit. They give them good shear credit, like an aluminum solid rivet. They don't give them any tension credit. And this would be a good case in point to say, well, okay, maybe the FAA is right. Because what's happening is these are failing in tension. They're being pulled on by that rocking action, and the moments developed there, and that eventually is loosening up the stem in relation to the body, and then ultimately it will lose its lock and then start on its way out. The worst case I've seen so far is 1 rivet gone of 3. 1 gone, left the building. The other one unlocked and very loose. And the third one, just looked like a bad rivet. So it's like, okay, if I'd had 3 like the one, I might have said, but it wasn't that situation. one was missing from the building. The second one was unlocked and on its way out the door. And as soon as that one had fallen out, there would have been some weirdness going on with that airplane, right? Because 3 rivets would not have been able to constrain it. And so it might have quickly gone to fail the 3rd rivet, or it might have just gotten to where the crank was not operating. Its push-pull was not working quite well, and that aileron was kind of going crazy, right? So who knows what was going to come next, but it had to be fixed.
And that would take out both ailerons, right?
Well, it's all a system. It's a loop. It's a closed loop. So
Loss of tension.
yeah, you might not have much left, or maybe you could crank all the way one way and still get a little bit. Hard to say. Like I said, that's the test flight none of us want to perform.
Yeah. You've got it attached with 3 rivets and 2 bolts, right?
Yeah, and the 2 bolts are primary tension contributors, right? So they also operate in shear, as do the cherries. But in our design, we only count on the 3 cherries. And first of all, those are the modern cherry, the current day aerospace cherry max. And those are counted on for their shear contribution. And then the 2 bolts go in. Those add a lot of shear capability, and they add a lot of tension capability. We probably okay, yeah, let's move on. I was going to say, all right, so let me get to Saturday 2. Okay, so this is full screen. Okay, so I'll be quick about this. So this thing, the elevator inoculation kit from Aerodyme, there it is. But let's go back here. So it's a bit of a maze now as how to get through the maze with your elevators. I think this was touched on last year or a year ago, 2 years, maybe by Glenn. But this is how I see it. If you still have OEM spars, so we go over here on the left, we see, in other words, untouched original spars, then every 150 hours, you would have to either tear the end rib out and go in and take the fitting off and have a look around, or you'd have to perform the global AMOC that was obtained by COG. And then at annual, it would be the same thing. So if you came to annual before the 150 hours, you'd the same thing. Now, if you have the Harrison spar splice, and Harrison's gone from the face of the earth, unless anybody really knows where he exists anymore, he apparently is absent the building. But anyway, Harrison had a kit that went in where you cut off the end of the spar, you spliced on a repair piece, a repair section. It made the hair rise on the back of my neck. But anyway, if you've got that in your elevators, then every 100 hours, you do an external visual inspection. And then at annual, you would do an external visual inspection. No need to go in anywhere. But at 500 hours, you would do a tear down, and that would be, tear the end rib out, go in, take the fitting off, take the structure apart, check it over, and then build it back up again. And that also would be or 5 years. So, and many of you who might have done Harrison have reached 5 years or beyond. And so you would be flying technically illegal on this. Almost nobody really is aware that did have that 500 hour and 5 limit. Now, if you have the Sterling spar, replacement spar, then just every 100 hours, you do an external visual inspection. Very similar to what you would hope is always being done on any control surface hinge anywhere on the airplane. Just have a good look. And if you have the Aerodyme elevator inoculation, this guy here, then at annual, you would do that external visual inspection. So you wouldn't do it every 100 hours, you'd do it just at every annual. There aren't any hours associated with it. And that would just be an external inspection to check the area, make sure there's no trouble. So when the Aerodyme kit is on there, the outboard elevator hinges get replaced with this guy you see on the left. And again, a little sophisticated, little fruit of sophisticated modern 5-axis machining. It looks like it might be rectangular and square and all that. It's none of those things. It's tapered, all kind of matches right in there. These little guys, these are the radius blocks. Once you've drilled this onto the spar, the radius blocks are sort of the washers. Then there's a little plate that goes inside the inside of the cavity in the elevator, which is just a nut plate to receive the bolts. And then these other guys over here are shims they go along the sides here to make sure that you get a perfect fit when you're putting this into the sort of the channel of the elevator spar. We want you to have a really good fit there. So there you have it. I won't spend much more time on this, but we could stop for a couple of questions.
It's a great kit. I installed it myself. Great install it. I think I'm pretty happy on everything. It didn't have cracks.
Jim, the original elevator side does not have bushings. It's just the metal on metal. It's the bolt on the metal, right?
Correct.
Now,
Correct.
Do you add bushings to your design?
No, we don't, because there should not be any rotation at that location. That would be this location right here,
Yeah.
which I'm moving my mouse on. So the idea is this should be a tight pinch install when that stainless sleeve sits in between those two lugs, and then you bring your bolt. You're done. You're ready. You're torquing up your bolt. You want to put the squeeze on that stainless sleeve. It's supposed to be pinched in there, not supposed to be rotating. The rotation should be taken inside the oil light. I should have put a pair of bushings in this picture, but rotation should be taken inside the oil light. And if that's installed properly and that nut is torqued up appropriately, it's not a high torque, but the instructions do give you a torque range that the castle nut should be taken to. And then if you can't get a pin through the turrets at that particular, you're allowed to go a little bit further on the torque until you can pin it. But installed properly, you won't have rotation going on there, and it's good service life. We didn't, way back in the beginning when we first stepped into this, 2011, I think, we were trying to get through the approval process quickly. I wasn't looking for a radical departure from the way Rockwell had done that hinge. What we were looking for are these side flanges that caused the fitting to be attached to the spar, not only at the web, but at the flanges. That was the critical thing. But other than that, we followed along pretty much with what Rockwell had done.
Jim, how does this compare to what Rockwell did when we took the airplane up there for the spar?
I didn't quite hear that.
How does this solution compare to what Rockwell was doing when you took the aircraft in for spar mods? Except for the original spar cracking?
Yeah.
Apparently Rockwell was doing some work on these.
Back around the time that, yeah, I don't have a lot of insight on that, what they might have been doing. I mean, we all know this is a service bulletin, forgotten the number off the top of my head, that talked about somewhat similar cracking at the top of the rudder. A service letter, I think it was. And it kind of, I think it touched a little bit on the end of the elevators, but they didn't really zero in on the outboard elevator position. They were really zeroing in up at the top of the rudder, and they were adding angle doublers and some things like that. But I'm not quite sure what they might have been doing in a early remedy program to do with those outboard elevator hinges.
Seemed like a couple of them had they had removed the hinge and broken the corners of the channel in the hinge, so it would drive itself into the radius of the spar itself.
Yeah, clearly installation was a part of this. Somewhere I have a list of what we thought were the contributing factors to the problem, and it's like 10 things. Are you using the control lock? And it went on from there. Sharp edges, all kinds of stuff. Build grain stretching during the fabrication of the spars and things. So yes, certainly that was there. And I've noted differences. We've done so many of these elevator repairs here that early on we were just doing them by dozens and dozens were coming in here. And we were noticing a lot of variations. The bolt holes could move up and down. They could position that sharp edge higher or lower and position it actually into the radius a little bit or not. So there was a lot of stuff like that was, just coming on from sort of fabrication and workmanship issues. Shall we move on?
I think we're ready.
Okay, and we still offer these. I mean, a lot of you have them in your airplanes. Hundreds of you have them in your airplanes. We still offer them. I've never changed the price. It's $850. It does both sides. It's PMA part. There's no added engineering charge, and on they go. All right, so Saturday 3, full screen. Okay, so a special airworthiness topic. Fuel senders. So, we've all struggled with our fuel senders, right? And level sensors in the fuel tanks. And of recent years, CiES has come into the field with some nice senders. As an engineer, I really wish they'd realized that if they'd done a single wire design, which they easily could have done, that would have saved us all a tremendous amount of nuisance installing these things. Power over Ethernet, right? Hey guys, you get one wire, shoot your power down, bring your signal back over the same wire, no problem. But somehow they didn't see that. But otherwise, they did a pretty nice design. And a lot of you are going to these. Now, I hadn't installed a set until recently. So our first foray in here only began about 3 weeks ago. We learned some stuff that I think all of you should know, including those of you who've already done this, because you may need to go back and check a couple of things. So we're looking at interference of the pigtail with the aileron cable, loose and inaccessible wiring, and increased unusable fuel. All right, here. This is the back of the sender inside the wing, the CiES sender. I just stuck it in there. Well, okay, what's going on over here where I have that red highlight? What's going on there? That pigtail is above the aileron cable, control cable, and directly riding on it and downloading on it. We all know where that leads. That CiES sender jacket is only a soft rubber jacket, and there is a power line inside there. So who knows whether the power wire is down near the aileron cable? I mean, you don't see it. It's inside the jacket. But that's a test flight I would not want to make. When that wears through, as it will over time, if the power wire were to come into contact with that aileron cable, things could get interesting. Here's the other case. I took it out and I stuck it through again. Okay, now it's underneath the aileron cable. It's uploading against it. So I called CiES on this and said, hey guys, are you aware this is going on in the Rockwell wings? They weren't. They made note, and they may take certain actions. I don't know. Maybe change their install instructions a little bit. But they said, hey, here's the fix. So they said, take your heat gun and form this pigtail. Okay. See that? Whoop. See that? The heat gun, we formed that pigtail right down. The key is you've got to keep that formation to extend backward no more than what you see here on the tape measure, like an inch and a quarter, because if you go any further back, you're going to hit that aileron cable. So this was great. I wish it had been in their install instructions, and I encourage them that they should do so for those of us who have potential interferences like this. And then you have to make sure when you do this that you've got the sender in the right orientation, same orientation that's going to go into the wing, because you don't want to form this up or outboard or inboard, you want to form it downward, right? So that the weight of the cable helps it stay away from that aileron cable. So the other problem is just access back here. There's exactly none. unless you happen to have the back of your wing open, which you seldom would, for some sort of repair back in the area of the cove skin or something like that. You might have the back edge of the wing open, and then you can actually see in here and maybe reach in here. But for your standard airplane that's just getting the senders installed, there's no access. So when I got in to run the wires for this particular set, first thing I noticed is somebody been in there before me recently. It turns out just before the airplane came to me, the Garmin shop had installed a Garmin flux gate out in this wingtip, and all that went great, except that when they fed the wire through the wing, guess what? They ran it right up over the top of the aileron cable. So you see it there at that red arrow. Their wire ran right up over the cable and down again, and that also includes a power wire. That's a shielded jacket, 22759 cable, and take a while for that one to really start to cause damage and wear through that jacket, get to the power conductor and all that. But anyway, this should not be what's going on inside your wing. So by some very tedious process, we were able to get this fixed. I basically had to drop the aileron cable, get everything untwisted, and then add my own wire, which needed to come in from the sender. But I had the continuing problem that everything was loose out in there. Out in that section of the wing just behind the sender, we had original OEM lighting wiring. We had some wingtip strobe wiring. We had this new wire from the Garmin guys. We had the CiES wire needing to come through. At some point in that wing, let's see, it's joined by something else. Anyway, 5 or 6 loose, just totally loose wires. The factory's tie down, stick down clips, you see one over here kind of, had mainly failed. They mainly delaminated, and 50 years will do that, right? So they're just let go, and so everything loose out there. So what happens when you get this big bunch of fairly loose wires running through your common cavity with your aileron cables, and now you fly in chop? Well, bounce, 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 bounce. So those wires are out there bouncing up and down. We just don't like it. They got to be tied down. So here you go. A blind installation clip. Here you go, a hole drilled. Now, first of all, you'd like to add an access cover to have some good access to this area of your wing. You really can't do that because this is beaded skin in this area, and there's not enough room between those beads to do a proper access cover, because an access cover can only be added where we can recover the equivalent strength by having a large enough doubler and so forth, and we have to recover what we've lost in punching a big hole through the wing. And there just isn't room there to do it in between these beads. But there is room to add a much smaller hole, 3/4, I think this is 3/4. And then and that gets me the access. You still have to be a surgeon. You have to work laparoscopically. So you have to go up in there with little fish wires, the pieces of safety wire like you see there, fish everything that matters to you, fish it all into a little bundle, ultimately attach this clamp, bring everything right over the top of it, and then tie it down. I don't have a full set of pictures on this because it's all brand new, but you can kind of get the idea that when you're done, everything is taken care of in there, everything is secured, and this little thing is on the bottom of the wing, painted to match, and this little plastic plug goes in, closes the hole, and there you have it. So that's one way to try to go in there and deal with just a loose bunch of wires flapping around. And so those of you who've already had CiES installed, I would suggest that you open the access cover in the wheel well. Wait, I have that picture. That's the one I'm looking through right here. So I got this picture by opening the access cover in the wheel well, just behind the tire, right? And then that lets you in a little bit and you look outboard and you go to see what's going on out there. You can see as far out as the sender. It's about 6 feet away from you at that point, but you can see it with the right lighting. And you ought to at least have a look and see what's going on with those pigtails. And if they're close to the aileron cable, you may not be able to tell whether they're actually contacting the aileron cable, and therefore you might have to take some action. But if they are well away from it, you got lucky, or the shop realized that they could form that pigtail and they've already done it, then you're okay. So this will only take you a half hour or so and a little frustration, and you should be able to see whether you're in any trouble with your already installed CiES sensors. And the last item with the CiES sensors is they don't fit the tank quite like the Stuart Warner or the whatever the other one is there, Rochester senders. The float for the CiES goes the other way. It goes inboard, outboard. It doesn't go forward, aft like your original float. It goes inboard, outboard. That causes it to sit a little bit higher in the tank when it's all the way down, as you can see here. This end of it that's close in the picture, this is the inboard end, right? So this guy is not going to float until there's more fuel in the tank, right? And the amount of fuel this is going to take is more than the 1 gallon unusable per side. I'll be able to tell you, and I'll put some sort of a posting up on .org, once we fuel these tanks on this job we're doing now, and we calibrate the CiES, I'll be able to report on .org how much fuel it took to float the sensor. So from an empty condition, where the tank is drained, the sump is drained, empty system, start adding fuel, wait for the CiES to start reporting, and note that exact fuel load when the CiES wakes up and says, oh, wait, I feel fuel. So if I had to guess right now, 4 gallons, something like that. It's going to be more than 1. I mean, 1 gallon isn't going to go very far. So then there's an interesting question raised is, okay, what do you do about that? And I talked to CiES about that, and they said, well, yeah, it's just a greater unusable fuel. And in a sense, it is, but nothing's really changed about the amount of gas your tank will hold and the amount of it that's able to be pumped to the engine to keep you going through the air. So that's still 1 gallon per side, but the gauging is going to lie to you below this ungageable level. Let's say this is 4 gallons or something. We'll find out. Then when you get down to 4 gallons, what's the CiES going to tell you? Is he going to tell you you're at 0? Or is he going to tell you you're at 4? What do you want him to tell you? It's kind of a trick question, right? The safe thing would be he tells you you're at 0. When you reach this sensor on the bottom of the tank, it's bottomed. The safe thing to do would be to tell you, the pilot, that you are at 0 and have you just know that actually you've got another couple of gallons in that tank to go, right? That would be a safe way to handle it. So anyway, I think there's more to this story, and we'll know better what this actual amount of fuel is within a few weeks. And like with any servicing of the fuel senders, you got to be careful that while you're servicing, your floats don't stick down. The old factory senders that ran the other way, they ran forward aft. They love to lay in the sealant. So your mechanic goes in, he gets these nut plates all sealed over and everything. And he's got sealant all over the place. And then he closes the tank. Fuel sender obviously has to be released. You can tie it up while you're working, but then you got to let it down when you're about to close the tank, and it lays in the sealant and it sticks there. So I know some of your mechanics have gotten to that situation. The CiES is a little less prone because it tends to sit on this outboard edge, and you can also turn it around. But I haven't done that. I haven't tried rotating. They say take it apart, rotate the rod. You could configure it the other way around. It isn't going to change the level detection at all, but it would change a little bit how it sits relative to the sealant and the nut plates. So anyway, be a little careful with that. Okay, so questions. Any questions?
I think we're okay, Jim.
Okay, then we're going to move on. How many, Don, could you take a quick poll there? How many people have CiES already installed?
How many people have CiES
How many,
sensors?
how many people currently have CiES installed? Looks like no one in this room.
No one. How many people have thought about it?
Oh, wait. Do you have this system installed in your plane?
The CiES senders.
The CiES sender, yeah, 3. Okay, we've got 3.
5 gallons, 10 gallons, 15, every 5 gallons, you calculate where the fuel was and tell the system how much fuel you put in. Now, if it's true that it only starts to register at 4, I don't know, but I at 5 it registered. I didn't see where it started to register.
Yeah.
But the question is whether if you have that JPI, if it gets fuel, let's say he realizes that 4 starts to tell you whether your fuel flow meter will then calculate it all the way down to M. If it knows or not, you know what I'm saying? If it knows what your fuel flow is, then we can.
Jim, one of the guys, were you able to hear him?
No.
He did the install and then went through the calibration. And he said by the time he had put 5 gallons in, the sender was already reading. So you may be somewhere in the ballpark at 4.
Okay, yeah, 4 or 5 gallons. It's my guess, but I'll report out on org what I actually am able to detect. Okay, so 3 or so already have CiES on board.
He was also asking if you know where your particular tank starts to register, if you go and build that into the compensation graph to say, okay, when I've got 4 gallons in there, it starts to read, that you would set your compensation then for the CiES indicator or the JPI or whatever you're using the totalizer and saying, okay, when it says empty, we have 4 gallons or 3 gallons.
Yeah, because there are kind of 2 ways you could go on that as the calibration tech, right? You could say that when the sensor bottoms, I know I've got 4 gallons, and so I'm going to tell the calibration routine that that's 4 gallons.
Right.
And so that's one way to do it. The other way, the safe way, is to tell the calibration routine that that is 0, right? Because the danger in telling it that that's 4 gallons is that it's then going to keep on telling you you've got 4 gallons all the way to actual empty. Right. And so somebody uninitiated who didn't appreciate this subtlety flying the plane and really stretching the limits might think, oh, I got 4 gallons. Well, maybe not.
I think they're looking at totalizer function. So the thing is, the totalizer's got a little turbine in there that's measuring how much is being consumed. And so it wouldn't necessarily be looking at CiES for a specific quantity. It would say, all right, when it's gone to a 0 indicator on the CiES, the totalizer is still going to be counting down that last 4 gallons.
Yeah. Yeah. And a lot of us have both totalizer and level, CiES level or whatever, factory level sensors. So yeah. Yeah.
So you'd be probably getting danger, Will Robinson from the CiES system saying you're out while the totalizer is still going down. Got it? I don't know who wants to fly with less than 4 gallons in a tank anyway, but
right.
Yeah. Ferries on the head of a pin.
Yeah.
That's a rare, I hope that's a rare situation.
More questions? We good? Okay, Jim, I think we're ready to move.
Okay. And we're going to move out to the hangar and just talk corrosion for a few minutes. But just before we go, let me mention one other thing. It just blasted back into my mind on tanks and senders and stuff. I've seen a number of reports come in and gotten some pictures of guys getting in to reseal the tanks, and some companies do a better job than others. But sometimes the presence of the anti-slosh valves is not understood or ignored, and the slosh valves will get sealed shut, and that's quite dangerous. There's a case just reported to me just a couple of weeks ago. They had to go back in, open back up again, clear all that out of there, and those are very delicate little valves, and once they're covered with sealant, very, very hard to clear it off them without chemicals, and then you're setting up new leaks and all that. The anti-slosh job is so that fuel won't get trapped in the forward section of the tank. So when you're on approach, right, you're coming in, you're basically angled down, right, nose downward, the negative angle of attack. And so the fuel will obviously flow to the front section of the tanks, because the tanks are split, forward aft, they're split, not quite halfway or whatever. And there are various holes and things that will allow the fuel to go where it wants. So let's say the fuel runs into those forward sections, those forward cavities of the tanks. Well, those slosh valves are trying to prevent that, right? When you pitch the airplane down, the slosh valve is just a gravity little flapper. It's supposed to close and prevent that fuel that's in the inboard section of the tank, right near the feed fitting, try to prevent that from running into that forward cavity. Because if you get a little further along in that approach and then decide you got to make a go round, and all your fuel is because your slosh was not closing properly, so the fuel has migrated. Again, this is sort of a low fuel scenario, right? And that low amount of fuel has migrated to those forward sections, then you can't necessarily get it back quick enough. So if you pitched up for a go around or something like that, you might starve one side or the other. So it's one of the reasons that I always figure that tapping 5 gallons remaining in any given tank is enough. That well, the first time that any system in the airplane indicates that I'm at 5 on either side, that's it. My flight needs to have already ended. But if you ever are in situations where this is getting pushed a little bit on one side or the other, then you got to be careful about those anti-slosh valves. So if you have somebody resealing your wings, make sure they know about it. Same like with the CiES thing. If some of you are thinking about putting CiES in, once you pick the shop that's going to do it, give them this copy of this presentation. Say, watch it. There's no two ways about it. Oh, we know exactly what to do. We've done it 1,000 times before. No, that's not the answer. The answer is, yes, sir. We'll take a look and we understand the problem. And so the same with those slosh valves. They've got to know they're there. They've got to just work around them and protect them in every way they can. Okay, we're going to try to go out to the airplane. Oh, Martine says there's something. Oh, yeah. Actually, I'm going to change screens here. Got a couple screens here. Okay, so we're going to do corrosion. So a lot of you are starting to face some fairly significant issues with corrosion, and obviously coastal, all that kind of stuff, the usual factors, dirt, grime, bad paint jobs, various contributors. So aluminum exfoliation isn't pretty. This is a good example here. You see the whitish area there. So that's exfoliated. This is how the plane looked when it came into me. So it was pretty clear in examining the flap arms that although there was some nice thick paint over the area, that something was going on there. And so with a little work, you see this. This shop had actually gone to quite some length. It turns out this wasn't the worst case on the flap arm. There was one that was much worse, and the paint shop had actually filled it with Bondo. They did a great job. They excavated out all that aluminum exfoliation, and they filled her up with Bondo, and they painted over it. And man, they were happy. And well, of course, that's ludicrous, right? They should have stopped short, called the owner, and said, "We see some issues with corrosion. These will need to be addressed before we can move on with the paint job." And that's what needed to happen, but it didn't. So we had to replace all 6 arms on this airplane because they were all in various degrees of this trouble. Now, this will get your attention. This is a wing spar lower cap. This is right where that lower cap is visible and accessible along the back of the wheel well. So if you stick your head up in the wheel well, you look aft, you see the spar. You see down at the bottom of the spar, there's this there's this significant aluminum longitudinal member. It's called the cap, right? The cap is the primary tension load carrying portion of the structure. When you load your wings up, positive G, this is where that tension goes. So the wing is obviously trying to bend up at the tip, right? And it's putting this lower member into tension. The spar web, the height of the spar, the thickness of the spar, that looks like, oh, that must be really strong. Well, not really. The spar web is doing different things, and altogether the pieces are making a beam, but the spar cap is a very significant contributor to the tension capability of the wing. Up above it, this is just a hydraulic tube coming through the area, right? So it makes the picture look a little weird. This is a set of calipers the owner had put up beside here. These calipers are set to the thickness that this cap is supposed to be. You can see here's a caliper tip. Here's another caliper tip. Oh, am I not on full screen? There. There's a caliper tip. So these are set to 1/4 inch, which is what the thickness is expected here. So you can see that we've lost a lot of that thickness. And these pieces down here are all the scab layers that are exfoliating off. Right? So these are a part of the spar cap, except that they're layers that have detached, right? And then all this area is all cruddy, and so you start going in with files and sanders and whatever, and you start exploring the degree of damage here. And this is a pretty bad case. So anyway, we want to try to get ahead of situations like this and not have to try to come in after the fact and figure out what the heck to do. So now I'm going to try to go out to the airplane, and I'm just going to walk around the airplane and just point out a few areas that we would be looking as a quick corrosion scan. Like you could go out to any one of the airplanes on the ramp there today, and you could quite easily look in about all of these areas. And you have to look kind of a little bit in your mind. You have to look kind of beneath the paint, right? I'm not asking you to remove paint from anybody's airplane, but if you see the paint looking a little bad, bubbles under the paint, little activity going on, something other than a smooth, nicely attached paint, then it is time to appropriately remove some of that paint and have a look and make sure things are okay. So we're going to try to go out to the plane and just go point out these areas. So I'm going to mute my Don, I think you have to let me unmute my iPhone 13.
I have to.
I'm telling it to unmute, but it won't do it.
I don't know what I can possibly
Do
do.
you have administrator function? Can you unflip it? Yeah, click on the. What happens if you click on the actual character down there where you've got blocked? No, I can let you do it.
Well, my host would like you to unmute.
Yes.
Okay.
I muted your computer for you.
Okay.
Yeah. Okay.
I know. There we go.
All right. So now.
Okay. So do you have my voice?
Yes.
Say again. I had to turn on my iPhone speaker. You got me?
Yeah.
Hear your
Hold on a
voice.
second. We've got
Okay.
a issue going on here. Yeah. Why? Anybody know why I can't get rid of that screen?
The one on the right?
This one. It was, did you see it was flickering? It won't.
Well, it won't minimize. Can you slide left to increase the share?
I will do that. But,
Or maybe I should stop sharing on my desk.
That's a possibility.
Let me try that.
that would be great. I can't do that.
Looks like you just stopped the share.
Yeah. And Don, you have that list of areas if you want to put it back up on your big screen. But
Okay.
I'll be going through them one by one anyway. So let me get this camera turned around if I can. Oops. Okay. All right. Here's Martine. She's going to guide us through the list. Wing spar lower caps.
This up. Okay.
This is what we were just talking about is wing spar lower caps. Let me get a creeper. So wheel well, under I go, right along here. Let me get some. Right along here. Can you hold that light? This guy. Right along here. See, and he follows. I see him going all the way out through here. About as far as you can see him is where he kind of disappears behind the trunnion. So all along there, and, like this looks good on this one. The paint is gone, but that surface looks like a good high integrity aluminum surface. I don't have any worries there. Here they had a little dirt when they sprayed the paint. Dirt picked up. That's really not a problem. What we're looking for is something that begins to look kind of nasty, typically. And if in doubt, take a little lacquer thinner or something, and in a little area along there, just take some of that dirt, paint off, have a better look, right? All right. Next. Flap hinge arms. Okay, so I think you all know where they are. But your flap hinges have the section that sticks down from the wing, and then the section that goes up and attaches to the flap. And it's right here. This is the hinge arm. This is a fairing, plastic fairing, aerodynamic on the front. This is the hinge arm. This is the 1/4-inch plate aluminum, which we seem to be having trouble with in various areas on the airplane. So that's the hinge arm. And my pictures were like typically down here at the bottom, is where you might start to see some trouble, but anywhere on them. And if you see some trouble, take the paint off, have a good look, see, is there any depth to it? The depth there, I think 1/4-inch, I'd have to look it up in my tables, but I think on the 1/4-inch thick aluminum, I think we're allowed 40 thousandths. No, not 4 thousandths. I think 4 thousandths is regarded as the and forget that number. It's a small number of thousandths. I'll look it up and I'll post it on .org. That's regarded as acceptable manufacturing variation on thickness. So if it cleans up within that allowable thickness, you're good. Just reprotect it, Aerodyne it, reprotect it, and paint it, prime it, paint it on down the road. But if it's nasty and the surface looks, like the picture I showed you, then there is depth to that. And you have to keep on excavating, right? Because exfoliation tends to be in layers and it can go into the material quite a ways. So if it's nasty, you got to keep on going. And if need, take this fairing off. Take your sharpened edge putty knife, go under here, tap, 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 work both sides. And this ultimately will pop off here. And then you can see the under section, which I wouldn't, if it looked clean without taking the fairing off, then I'd say I'm good. But if it was looking nasty and the nastiness went right up to the edge of the fairing, I would take the fairing off and make sure I understood the extent of the nastiness. Okay. fuselage T-straps. Okay. Again, it's these thick aluminum members that seem to be causing us some trouble. This is a fuselage T-strap. So I'm under the belly of the airplane, obviously, and this strap sort of carries loads underneath the wing spar, connects the forward part of the fuselage to the aft portion of the fuselage, carries loads under and through. These sit down in the exhaust contaminant stream, which doesn't help. And they're on the bottom of the airplane, which doesn't help. And some of those have been ending up in pretty poor conditions. So keep an eye on those. Next, battery support structure. Yeah. Oh, I can't see it. But, the boss says I'm not going to see the battery support structure very well, but let's go. Let's go looking. So far, these are places you can all easily look, right? As owners. Right? Nothing too difficult so far. So battery support structure would be underneath the battery box. So I can't see what's on my picture, but see if we can do you any good in here. Just get one of the yellow lights. They're on the desk. So you got your battery, and then it sits in the plastic box, right? And then underneath that, there's the aluminum structure, which the battery box is maybe screwed down to. Although many of them, those screws are gone because they've corroded to oblivion. And so the box isn't really screwed down at all. All right, I'm going to try to set this light here. Light in the... All right. Okay, there's a battery, there's the battery box, and there's the understructure down there, that aluminum understructure that's supporting all that. So this area tends to get hit fairly hard because of the presence of the contaminants from the battery and the all of that stuff. Okay, next. Yeah, belly skins. Okay, so the belly skins tend to take a hit because they are on the bottom of the airplane. And you also can have stuff running out, collecting in the belly and then running out through and kind of laying in place on the belly. Get some cords out of my way here. Yep. Set my creeper down. Okay, here we go. Belly skins, particularly from midship back. Like we looked at the support tee a minute ago. This rivet line right here, right? Good place to look. That skin lap, that rivet line. And then you come back, there's another one. Here about inboard of the flaps, right? Move forward to there. There's another bunch of structure here. A doubler, a skin lap, a rivet line. Come on back through these areas. Come back here. Now here's the step. I'm going aft of the step a little bit. Another skin lap, rivet line. So sometimes the contaminants escaping from these areas will set up little galvanic cells and so forth and start to attack those areas. This airplane looks good, but a lot of them are in some trouble in those areas. And those, if you find anything going on, you want to get to it sooner rather than later. Okay, next. Okay, so again, another use of 1/4-inch plate, aluminum plate, was the stab half of the elevator hinge, the outboard, that elevator outboard hinge we were talking about earlier. Stab half, this guy, right? He's 1/4-inch aluminum plate. Okay, so I've had several of those come up in the past year as being pretty nasty, corroded messes. So that is a part that we offer. It just unbolts and can be replaced. And if it's involved in any serious corrosion, it should be. Okay. rudder hinge. Rudder hinge stab half. Yeah. Okay. I know where we're going. We're going up to the top of the vertical stabilizer. And my goodness, we find Tyler here doing some scanning. Okay. So this guy. So the vertical stab half of the upper rudder hinge, same thing, 1/4-inch plate. So have an eye on him and his lower brother. Oh, not yet quite on this guy down at the bottom. This is the lower rudder hinge stab half or fuselage half, let's say. 1/4-inch plate. Again, that may be under attack. Okay. Wheel halves. Yeah. Cleveland junk. I have the covers on this one, but the wheel half. So when your wheels are being serviced, the mechanic may have already said to you, ooh, these snap ring grooves and so forth, they're looking pretty nasty, when they're because they'd be expected to be servicing the bearings, remove them, clean, lube, put them back in, and they might notice that those wheel halves, those aluminum wheel halves, are pretty nasty. And eventually they do, they just crumble and decay to the point where they won't retain the snap rings. And so the felt seal and so forth will just kind of flop around loose in there. It's not a structural exposure at that point because it's just a grease seal. It's a service exposure, but it does continue. That decay and that corrosion will continue to eat into those halves until you do have a structural issue, because the bearing race can no longer get adequate support from the there we go, can no longer get adequate support from the structure around it. So keep an eye on those. The disappointing part of that story is that when you order a new half, when I just realized I have a nose wheel here, we could have looked at. So, we're talking about, right in here where the snap ring groove and so forth, right inside the structure here. The disappointing part is that if you order up the new Cleveland halves because you figure that it's about time to do them, and you install them, then 2 years later, they look the same. So, well, not really. They're not quite as advanced, but it is disappointing how quickly that fresh, brand new Cleveland product gets set up in corrosion again. So keep an eye on those. We have seen a couple cases where we did have to definitely replace them because the races were being undercut, right? So the corrosion had begun to undercut the bores where the races press in to the wheel. Okay, now some steel items, because that was all aluminum so far. So where are the steel items on the plane? We'll touch on some of those. The motor mount, that's an obvious one, right? That, of course, is steel. All right, so motor mount. And in particular, I would pay attention to areas that are close to the exhaust, and they may be seeing some heat, right? Particularly on any turbocharged models. They may be seeing an unreasonable amount of heat. There may be shields in place. There may not be shields in place. And heat will definitely accelerate the corrosion. So you want to look this guy all over. The joints are very critical, right? So we look at the joints all fairly closely at annuals to make sure that we don't see any sort of cracking or detachment or whatever. And it's got to be reasonably clean to inspect it, right? So don't try to inspect it in a laid in with crud condition. Clean it up. Okay, let's see next. Gear strut tubes. Okay, so the strut tubes are plated steel. Here's an example of a strut tube. Okay, lots of times you'll see it first start to set up right down here around the lower edge. Don't seem to see any problem there. Let's go over and see the other one on this plane. I don't think I've squawked anything on this one. No, pretty pretty clean. But when you start to see it there, it'll start to build up, go higher and higher on the tube. And ultimately it'll go high enough that the corrosion, the scabbing and stuff will enter the seals when you go to full strut compression, hard landing, whatever, it can enter. And then it'll start to take the seals out. So you don't want to let that go too far. A little corrosion there, down low. I think you just watch it. But if it starts working its way up too far, then you got to think about some new tubes. Yeah, I don't think we had a problem on this airplane. Okay. So, gear actuator rods, kind of same story. Gear actuator rods. We need the light this time. Going back under the wing. Gear actuator rod. Okay. So, clean the rod off. That's just a buildup of dirt there. Clean the rod off. Normally, when I'm doing my TLC on these tubes and rods, normally I would take a rag damped with avgas, just damp, and I would wipe all the crud off, right? And then when I had that crud all off there and the avgas had sublimated, I would then take a rag damped with 5606 and I would just rub it, right? Just put a layer of film of 5606 on there, and it won't last long, but if you do it every 3 months or something like that, then it really will improve the situation. It's also helpful when you're dealing with the struts to occasionally go up in here. There's a lot of crud up there, right? I can't really show you with the iPhone, but there's a lot of crud up in there, up in the area of those seals. And some of it, obviously, when the strut articulates up and down, some of that gets carried into the seals, right? So we don't want that to be a big crud zone. So it's best to flush it out. And really, cleaning agent, you got my sprayer? No. Cleaning agent that is safest on airplanes is, wait, do I hear it? Avgas. It's not necessarily great for you, but it's not going to hurt anything. Airplanes know about avgas. So I take my sprayer and I stick carefully with myself protected, stick the nozzle right up in there and flush that out. Then take an acid brush, you know what I mean, the kind that's got the bristles coming straight out the end of it, and kind of work that up in there around, work it with acid. Go ahead, you can get ahead of it, behind it. Then flush it out again. Now it's nice and clean. You look up with the mirror, it should be nice and clean in there. And then do that business about the little film of 5606. Next. Okay, Zeus. Yeah, the Zeus wires. Wing, filler, cap is off. Zeus wires. I think I've got these on the squawk list for this airplane. Do you have the light? All right, so there's the Zeus wire. You're always going to see some corrosion on them down in there. In direct viewing this one, I'd say that probably the maximum depth of diametric loss I'm seeing is still within 20%, something like that. If that diametric loss or remaining wire is getting anywhere near 50%, then it's time to think about having those out, replacing those Zeus wires. Also, because water tends to sit down in the hole. See that rust down in there? There's some water sitting in there right now. That will sometimes perforate the bottom of the cup, because there is on the bottom side of this flapper, there is a cup that's all contained in, and we've seen the cups perforate. So then you can't develop the proper seal anymore, because there is always some leakage. And if the cup is perforated, big hole right in the bottom of it, you really can't develop the proper, the best seal. Okay, cabin door hinges, Martine says we're up to. So steel, right? And sometimes if your paint has gone down the road pretty well, these will start to corrode. And, again, I don't think too many of you are going to find hinges that are corroded to a safety issue, but you may find hinges that really where it needs to be stopped. You can put an end to it. So again, just go ahead and put an end to it. If you encounter rusty, surface corrosion and a fair amount of it, then clean them up, take care of those.
Okay, cracked.
Cracks. What do you have?
Cabin steps.
Cabin steps. Yeah. Oh, and by the way, here's another cabin door hinge. You see these two rivets here? 3 screws. Everybody's going to find 3 screws. Okay. This build, there's also a pair of rivets here. These are keeping this hinge from bending away, from bending right here. The technique we use is a 4th screw. So we've got 3 now, add a 4th screw. I can send you little pictures of how to do that, particularly if your hinges have started to bend, right? Then it's time to put a stop to that. That is tempered steel. It's not designed to bend. So it's fairly brittle. And we don't want one of those to keep on bending and get to the point where it could actually decide to break. So the 4th screw, remember in your mind the 4th screw. It's on my inspection checklist. Hon, where'd you go? Oh, elevator horn weldment. Okay. All right. So, excuse the strange apparatus here associated with scanning. But this is we're back at the tail. Here's the elevator horn weldment. The elevators are obviously off the airplane. But there's the horn weldment, all steel. No drain hole. There's never been a drain hole provided. So these do fill with water. The water ingresses through the bolt and so forth. They fill with water and they can get really nasty. I've never found a case where the internals were more worrisome than I thought they were going to be by looking at the exterior. Conversely, when I look at the exterior and I see a rusted relic, then I worry that same degree of corrosion could also be set up on the interior and begin to wonder about the remaining integrity. So we have had to replace a few center fittings, and it's good to keep up. If they're pretty nasty on the exterior right now, take it down off the airplane, take a borescope, look at the interior, try to flush it out a bit. And if you decide it's good to keep on down the road, then give it nice, fresh primer and all that. And I find what works quite well for priming the interior of those things is, what do you call it when you turn the turkey on your grill? The rotisserie. You buy the rotisserie at Ace Hardware, and you plug one end, you pour some primer in there, you slosh it around a little bit, and then you end up putting it on the rotisserie, and you just let it turn while it's drying, and that will tend to spread the primer out. Otherwise, it's very difficult to paint the interior of those things. So at least it works somewhat. All right, let's see. Martine is calling me to the back of the plane. Oh, the push tube. Okay, the elevator push tube. Being the guy that runs up and down from the horn down to the crank, the elevator control crank down here. So the push tubes are sometimes quite nasty. They are all steel. Here's one on the table here. This one's pretty decent, right? It's got the usual little surface corrosion spots and things like that. But where it counts, that's primarily, I looked at that the other day. That's primarily just a surface coloration there. I didn't have any real worries about this one. If you're doing any sort of major tail disassembly, then it might be nice time to just extract this tube and media blast it, not sand blast, but media blast with skunk pea or whatever you're using, and then prime it, get it right back to nice condition. There is a typical chafe point right up in here where the push tube passes through the fin rib, right up there. A little hard to see, but right up in there. Fin rib port, push tube passes, see the U cut there, passes through there, and sometimes they're in contact and they will continue to scrape the push tubes. So if that's happening, call me up. There's some ways that you could think about taking care of that. Rudder horn weldment. Say, where do I have a rudder? Right here. Okay, this rudder horn weldment, this is a rudder. This rudder horn weldment was in all kinds of trouble. It was a nasty mess. So this guy, the horn weldment itself that has the tube on it and the foot, this is steel. This is all steel. The bottom rib of the rudder is aluminum. The horn weldment also comes up inside and attaches up in this area. So it's not just the tube you see out here. It goes in and then has a truss and connects back across the face of the web with additional fasteners. And this one was just a mess in the entirety. We cleaned it all off, decided that we really didn't have any structural worries, but it needed protection so that things weren't going to get a whole lot worse. And so cleaned it all up, primed it, and going back in as a part of this rudder rebuild. This rudder had all of my list of typical issues in structural cracks in the spar, cracks up the top, cracks halfway up, everything. So taking care of it.
Control cables and terminals.
Okay, control cables. Control cables and terminals. Our friends in Australia, 5 years ago or so, put up the alert around the aviation community that they were finding cases where the control cables, aileron, rudder, elevator, or the whole litany of them, with the wire was actually pulling out of the terminal end, right? So there was corrosion going on internal that you didn't see. The wire still looked okay. The terminal end still looked okay. But in fact, there'd been corrosion in there in that interface, which is a stress interface because it's a crimp in the beginning. They crimp it when they make it. And those stresses that ultimately led to corrosion start, and then water ingress and all that. And they had some of these pull out. So they now have an AD in Australia that says that these all have to be carefully inspected each annual. What I would say for you guys is be aware of the condition of your control cables and terminal ends during every inspection. Make sure that there's a specific look at those. And if anything really looks the least bit suspicious, then it's time to think about maybe replacement or what comes next. That's it. Okay, so that's it. So Don, I think we could take any final questions and then I'd be out of your hair.
Yes. Look at the step. Oh, Jim, if you're handy there, do you want to go over to the step weldment junction where we get all those cracks?
Yeah.
I mean, a lot of people have heard us rail on about it, but there may be some new ones that aren't familiar.
Yeah. Okay. Yeah, and I think that is important. All right, so step, okay, tread, and then this is where we get in trouble right here. The cracks will usually first show up here in the front, or maybe here in the back, and sometimes it's hard to discern a crack from a flow edge in the weld, because a weld has a flow edge where the flow stopped. Sometimes that looks a little bit like it might be a crack. So you have to just take a close look at them and then step on them. And I don't think I can hold my camera and do this at the same time, but put your weight on and keep watching, or have somebody else step, keep watching and see if anything opens up. Oh my goodness, Tyler, were you right in the middle of a scan? Tyler says it's okay. You might have to restart that one, huh? I wiggled you pretty good. Okay. All right. So if you have to have your steps repaired because you've noted some trouble, then what you want to do is have a back gusset installed. So what they can do, any pretty good welder will cut a slot here, goes down onto here, right? He's going to slot this, two. Then he's going to make a triangular gusset. He's going to insert it inside there, and then he's going to weld up, right? So that now you've got a gusseted transition here, and it's very clean. It's on the back side. You don't see it. We've done it many times, and it really puts you in a forever mode on those, as long as you've got good protection and paint.
Thank you, Jim.
Yep.
Any other questions? We're running a little long, and it looks like the questions have been answered.
Okay, well, thank you all very much. I really appreciate your time, and I welcome your calls about your airplanes at any time.
Thanks,
Thank you
Jim.
very much, Jim.
Okay, bye.
Before we break lunch, just have a couple of admin things. There's one shirt left. It's a double XL. If anybody wants that. The session we have after lunch is going to be an open forum. So it's bring the questions that have been on your mind, challenges that you're having. I've got my list ready to go. So if nobody else has questions, then I'll ask mine. And
We want to try to do the team photo.
yes, we'll get to that last. But yes, we're going to try to do a photo since you said it right after this. Let's get out here. We got the airplane still out there, right?
Yes.
Perfect. Figure out the best place to do it. Tonight, remember, we got the Yankee swap at the end of the banquet. So if you're still time to go get a bottle of wine or, something for that if you haven't. And remember that they prefer cash at the bar here tonight. You're not going to be able to use your credit card here.
Green.
Yeah, so legitimate cash bar. All right, anything else?
I think that's.
You got anything? All right. So, yes, sir.
I want to leave it in, but I had an incident when I departed Salt Lake, and then Jim showed the elevator point. I departed Salt Lake in a bad rainstorm and had to go to 360 going east. And elevator was out. Since I have closed the elevator, but I'm to the office here. And it was bitterly frosty, you could not move it. So I went east with the trip tab. Well, when I got out of the rainstorm, so I might.
Yeah, it's melted.
That's what time I almost got the rich.
That's actually something else for people who don't have anti-ice.
Where's Ed Williams? Haven't seen.
If you have some of the aircraft have fairings over the trim tab, push rods go out of the horizontal tab. If you don't have those, and there are lots of them that don't have them, you're flying in weather that is subject to ice, those can freeze in position, and you will have no elevator trim until it thaws out. So sometimes, if you know you're going to be going through a layer and you want to make sure you're planning that way, you are better off set the trim closer to cruise and simply overpower it until you get through your layer. And then if it does freeze, at least you're frozen in cruise position, as opposed to having to fight it the entire time you flight. So you don't fight anybody.
Do you really have Ed Williams' contact information? Phone number? No.
Team photo outside.
once